If you went to a store to buy chips and drinks, how could you figure out how much money it would cost? One way is to multiply the price of each item by the amount you're buying. So, if you bought 3 drinks and 2 bags of chips for $2 and $3 per item, you'd end up spending $12. This situation can be represented as a linear equation, and it's another formula, standard form. AX plus BY equals C is standard form, and there are a couple rules to remember. First, A, B, and C should all be integers, which are whole numbers, not fractions or decimals. And second, A should not be a negative number. How does this equation relate to our chips and drinks scenario? We could write 2x plus 3y equals 12 to describe it. 2x represents $2 times the number of drinks purchased, 3y represents $3 times the number of chips purchased, and 12 represents the total money spent. Here's an example of how to graph standard form equations. First, you may notice some differences between slope-intercept, point-slope, and standard form. Standard form is the only formula that has both x and y on the same side of the equation. In addition, it does not include the slope and either the y-intercept or a point on the line. Therefore, we need to take a different approach when graphing, and one method is plugging in zeros to plot the x and y-intercepts of the line. Here's what that means. Since y-intercepts always have a 0 for their x-coordinate, and x-intercepts always have a 0 for their y-coordinate, we can plug in zeros for x and y in our equation. Let's start by plugging in 0 for x. 2 times 0 is 0, and that leaves us with 3y equals 12. Then, we can solve the equation by dividing by 3 on both sides to get y equals 4. This means our y-intercept is 4. Next, we can plug in 0 for y in the original equation. 3 times 0 is 0, and that leaves us with 2x equals 12. Then we can divide by 2 on both sides to get x equals 6. This means our x-intercept is 6. Finally, we can draw a line through the two intercepts. Another method for graphing standard form equations is to not use standard form at all. Instead, we can convert the equation to slope-intercept form and graph from there. Here's the same equation, 2x plus 3y equals 12. If you remember, slope-intercept form is y equals mx plus b. To convert standard form, notice how mx needs to be on the right side of the equation. To move 2x to the right side of the equation, we need to take it away from the left side. This means we need to subtract 2x from both sides of the equation. 2x minus 2x on the left side equals 0, which means it is cleared out. Then, on the right side of the equation, we are not allowed to subtract 2x from 12 because they are not like terms. 12 does not have an x. Therefore, we can just write negative 2x plus 12, and our overall equation is now 3y equals negative 2x plus 12. We're getting closer to slope-intercept form because our mx is in the correct location, and it looks like we have a plus b with the plus 12. However, there is one more step. Slope-intercept form says y equals mx plus b, not 3y equals mx plus b. This means we need y without a number attached on the left side of the equation. Therefore, we can do a step similar to what we normally do when solving equations. We can divide by 3 on both sides. The only thing that feels different is that we have to divide the whole side by 3, and here's what that looks like. Negative 2 divided by 3 can be left as the fraction negative 2/3 because it cannot be simplified further, and 12 divided by 3 is 4. Therefore, our final slope-intercept form equation is y equals negative 2/3 x plus 4, and if we graph it, you'll notice it has the same intercepts from before when we plugged in zeros. We won't spend much more time with standard form in this chapter, but we will get more practice with it in upcoming chapters. For now, work through the upcoming practice problems to get warmed up.